But here there is something that I can use, and that is this sweeping arm here, which is like a kind of reaction wood that's grown. Aslan. I've only got a limited amount of timber for this job. This is the reject pile really from that job that I did a few years ago, about 2 years ago. Well, they're not the best pieces of timber, they're a bit twisted. I need to try and get the most out of them. This not really long enough to do what I really wanted to do. But if I cut the bit that sticks out of the wall at an angle, I can get longer pieces from each piece. So as I've done a zigzag here. So the bit that sticks out over the wall is much smaller in dimension than the bit that's inside the building, which looks very nice anyway. So that's a good thing. But I spent some time today making this timber dog. I thought I would try it before I film anything like this, so just thought I would see if it worked. So I've got one here that's fixed but can spin, and then this one goes in and out. So you can fix it in the timber and then adjust how much. It's an adjustable dog. I've wanted one for a long time really. You can buy them, but I thought I've got everything I need to make one, so it took about an hour and a half to make. I find myself now in a fairly typical situation for doing these kind of mathematical building systems. Which isn't really. Most building systems are mathematical. I have these pieces of timber here, they're quite short. I want to get them absolute maximum out I can. I don't want to have too much. I'd like to have a little bit of roof, tarkud stick as it's called, roof, the bit that sticks out. Don't know what that's called in there. It's not an eave, but it's a bit like an eave. I don't want that to be too short. As it is, I think I've managed to make about 30 centimetres, which is a bit short really. I would have liked it to have been 50. But these are the pieces of timber I have, so I'm going to use them the way they are. I've decided to go for a fourth in height. It's called a fjärungsrust in Norwegian. It's a fourth of the width. It's very traditional. 27.5 degrees. It's halfway between the push and pull of the wind, so it's a very good angle, roof angle. It's that angle. Very traditional all over the world, especially in coastal areas, because it's halfway between the push and the pull of the wind. Any steeper and the wind pushes on the roof, any lower and the wind lifts the roof. So it's, I don't know, yeah. Maybe this angle was arrived at by the houses that survived hurricanes, possibly. Anyway, it builds, in my construction, for this 4 metre opening, it builds 1 metre up. But exactly where the points intersect, it depends a little bit on how I construct the roof thing. So it's typical, I need to know exactly where all of these things are in place before I can even make any progress on the 2 pieces that go the top plates. The length of the building, because I want to cut all of the parts to the top plates down on the ground here before I lift them up. So I need to know exactly where all of these, what I call spadre, these the roof beams. Maybe they're called joists, roof joists in English. Just correct me if I'm wrong with these things in the comments. So I've drawn this out several times and moved it around a little bit because I'm trying to get the best possible combination of parts. So I'm going to make these pieces, I'm going to get more out of these by cutting them at an angle, not straight across. That way I can extend the distance that sticks out of the roof. I had to go with a slightly smaller, steeper angle. That makes a smaller point at the end, at the very outside tip of the building, which is kind of okay. It's quite strong, but I think I'm going to go for one that's slightly less angled, a slightly more oblique angle. And then this little, the end piece, the kind of point that is made from doing that process will be hidden down in the top plate. It'll actually make the kind of stop piece for the top plate. Difficult to explain in words. I'm just going to do it now. So I've settled upon a correct depth for the saw, angle for the saw, and I'm ready to start cutting. I've also decided to use a ridge beam, which is another way of allowing myself to use less timber. So I'm going to mark it with an arrow and a circle. So when I make mistakes in marking, I used different marks. So an arrow and a circle. Move the timbers. This is why I would normally use a chainsaw for this kind of thing, but I need to save the material. I don't want to lose that much material. The curve of that saw there is just 3 or 4. Actually, the chainsaw is probably almost a centimetre. So you see, I've got now a thicker piece of wood sticking out above the wall. Get that blade through really, I'm going to drill it. I'll just drill it where it probably matters least, and that's right in the middle. That's really good, that's come out exactly in the middle of the other one. Battery dead. I kept that at 7 centimetres because that gives me enough space to use 75mm nails without them coming through. Three-inch. That is for the Americans.
He's a good boy. That's that. Yeah, he's a good boy.
That's nice and square. It's quite square. Yeah, it's square enough. Good enough. 2mm maybe difference. That's good enough, I'm sure. I can always fiddle around with it a bit later. Clean up in that corner a bit. Same here. Just use this one as a template, and I put in the centre mark of this one onto the centre mark of this one. And that should be 7. Right in a split. A little bit. That's a little bit unfortunate. This isn't quite square here. I'm going to take the squarest side. feels right. Yeah. That should be good. I might do that the other way up because there's a big split here and it's kind of guiding the blade a bit wrong, perhaps. I don't really do that for aesthetic reasons, I do it because I don't want to get splinters when I'm carrying it around. .268. It should be 268 long. So this is 51 2 centimeters too short. I don't have any more of this kind of material, and I don't really want to use. I don't want to buy a piece. I haven't got any wish for that. But what I have got is another short piece. So I've decided to make a long join. So I'm thinking that I might do something this and do one that goes back and one that goes forward, so there'll be like a fork, but with one slope this way and one slope that way. That way it's good for all the different directions. And I think that's more suitable for something that's being loaded downwards alone than doing a French, I don't know what they're called, a French one, which is like that. That type is good if you want to have strength for sideways as well, but there's actually, I don't think it's as strong for the downward pressure as that one. So I can use the same 27 degrees is fine. It's already up for that, laid up. So that one goes that way, so this one will go this way. And then I'll go thirds. So that one's 16, this one's almost 16. Something like 5.2, is it? 5.2, 10.4. Yeah, it's 5.2. Might use the other end because I think this has been down in the ground, so it's probably quite a lot expanded by the water, whereas this piece here has been sticking up into the air. I'm going to use that piece. I think I might put the split on the side actually, because I don't really want the bit that I'm going to have too much of a split in it. I've got a split in every direction, but there you go, anyway. .2. Grey on the grey doesn't actually stand up very well, so I think I might use a red one. Oh, that's rubbish. rubbish thing now. That's Emma making rubbish things. Much more effort than it's worth, that thing. Rubbish. I think I might do them quite long. I'll make this slightly shorter than 60. 59, that gives me a centimetre, a gap there that I can put a wedge in if I want to. I'll just make that one square. Because that one should be square too. I might even glue this. Or at least put a couple of bolts in. I could probably pull that a bit further in. Just have to find the So I'm going to put a couple of small screws that pull. No, that type there, that's what I want. The ones that have a different thread, so they pull together. Now it's quite tempting to put a strap around the outside as well to pull the pieces together, because I've only got one shot at this. The reason why I have so many of these lorry straps is because I use them in restoring old buildings. We use them for holding pieces of timber up, for example, or putting a building back together. Sometimes buildings have lost parts. Wind braces, for example, very often farmers take wind braces out of barn buildings because they get in the way. They bump their heads on them, I think, is really what it is, and they don't like bumping their heads, so they take them out, and then the building get weak and fall apart. So by giving that pressure there, they work kind of dependently of each other. So if I move it that way, this one's opens up and that one's tightens down, and if I move it that way, it's the opposite. So whether or not this is flush or that is flush doesn't really matter. The two pieces of wood are different. What matters is that I get these joints tight. So I want the one underneath to be as tight as the one on top, that's the point. Before I put in any screws, right, that's looking good now. So now I'm going to put in a screw here, sideways, and then I'm going to move the strap to the other side and put one in. So I want the screw to have pressure on it, but I don't want it to be working too hard. Actually, it wasn't the screw that broke, it was my bits. So this is to pull them together so that it's nice and tight here, and then I'm going to bolt through these to add the friction that we need to make it nice and sturdy. My joint isn't perfect, but that's because this isn't furniture. I don't want to spend all day making one of those really, really beautiful. I just don't think it's necessary. What is necessary for me is to get the bits that are actually going to be doing the mechanical work of making the piece strong nice and tight. I should have looked more carefully. There's actually a split already there. That was a shame that I put that right on the split. I can't hold the other side, I need to go and get another tool. See the growth patterns? Just try and use a different line now. There's another battery gone. For grinding, but there we go. It's almost finished that one anyway now. I think it's just as well to bevel the edges like that, because the amount of time you spend trying to get the nut on when you haven't done it. It would of course be better to use a 10mm hole as well, but again they get stuck, so really I can't get them through, and I want them to pull together. The job that this is doing is one of pulling the pieces together and creating an enormous amount of friction between the two pieces. As well as that, I've got these two surfaces that work against each other. When you try and bend the piece of wood, those pieces get pushed harder together. So this is a very strong connection for a load that goes on top, downward load on it. But it can never pull harder than the strength of the fibres, so that's why it's good to use several. I could also, of course, use much bigger washers. That would have it would be very beneficial to have bigger washers too. Nice thing about using small bolts is that they don't make big holes. The drill bit that I used was 12mm and the bolts are 10, so I could have used an 11mm drill bit, or could even have used a 10mm one, but if you do use a 10mm one you spend a lot of time trying to bang the pieces of thread through, which isn't necessarily very good for them. And I want it to go on easily because I haven't got anything to hold the thread with, because I've cut the thread a bit shorter that time. It doesn't really need to be as long as those ones. But this piece isn't actually going to be all that long, in fact. So this comes very near the top of the joint, so it's not as if it's got the full load that it'll have on the middle of the beam here. I mean, in a sense, I suppose I perhaps could have made it a bit shorter to keep this beam as strong as possible near the middle, but I'm sure this will be fine. Just want to make a quick template. I just want to go and check with the other ones that it's about the right width. And I used the lowest point, the thinnest point of the timber at the other end, and that goes in relation to the meridian line. So everything is in relation to the meridian lines. This is in relation to the meridian line, which should be 4 meters apart. That's how I get my mathematics to be correct. Because when you make triangular constructions, there's no margin for error really, because they meet at a point. So if it's wrong, there'll be a gap. So I try and get it perfect, and then it makes it easy to put together later. So if I make a mistake, at least it'll be near correct. That's the idea anyway, hopefully.